let's get this party started. We're now working on section 6.3. We're going to have multiple angles. This question right here is in your book, number 25. We're actually going to do this one in class. There are a lot of steps. I don't want to waste your time. So here we go. Let's move on. There we go. Okay, first question. We want to find all solutions between 0 degrees and 360 degrees. We have cosine 2 theta, which is equal to negative square root 3 over 2. Right away, I want you to think about, okay, the square root 3 over 2, negative square root 3 over 2, what type of an angle is that? Well, I'm going to make my unit circle right away. First thing I want to do, make a unit circle. Okay, from there, I know I'm working with cosine, so that's going to be the square root 3, and it's negative, so negative square root 3 is going to be my adjacent side. And now my hypotenuse is 2, and it's going to be this way also. So beautiful looking triangle there, huh? So, and then just for kicks and giggles, I'll do 1 and negative 1 for my sine, or my y value. Okay, now we need to find all solutions where this is true. Okay, so right away I'm thinking, okay, I have 2 angles that are in that quadrant. Okay, so we have 150 degrees, because this angle here is 30 degrees, and this angle is 30 degrees, our reference angles are. So 2 theta is equal to 150 degrees and 210 degrees. But wait a minute, think about this though. We have 2 theta, just a theta over here. We need to make that 2 theta. So if we multiply this by 2, this by 2, this by 2, we actually are looking from 0 to 2 theta all the way up to 720 degrees. So we're actually extending this area that we're looking out. So really, this is going to be 150 plus another 360 is going to get us to 510 degrees. And then 210 plus another 360, because we're basically doubling the angle, is 570 degrees. Okay? You can kind of see the relation. There's 60 between these two and 60 between these two. Now if we were to go another circle, so far we've done 360, and then we went 720. Well, we hit right here twice, which both angles are accounted for. All right, but wait a minute, we want to know what theta is. So in order to solve for theta, it's just a simple divide by 2, everything by 2. Because we're looking for 0 to 360, okay? So now theta is equal to, that's a good looking theta. Theta is equal to 75 degrees, 105 degrees, 255 degrees, and lastly, my favorite, 285. I don't know why it's my favorite, I just like 285. It's a cool number. Okay, so that's going to be, that will be our answer. It's just that's what I'll be looking for. So there's a lot going on, but it's not overly difficult. The big thing is to think about your unit circle. Okay, once again, looking at the next question, first thing I want to pop in my head, I have sine 3 theta minus 1. Well, I'm looking over here and thinking, okay, I have 0 to 360 degrees for theta. Well, let's get that so it's 3 theta here in the middle. So we're going to multiply each one by 3. 3 times 3. So we're looking from 0 to less than 3 theta is less than the 360 times 3 is going to be 1080. So 1,080 degrees. That's this. Now, right away, you should be looking at this negative 1. and thinking, okay, that's sine is -1 where? So I'm going to draw my unit circle. Let's change color here. -1. Sine is -1 in one spot. Right there. That's pretty much it. Well, what is that? What is that angle? That angle is 270 degrees. Well, remember, we're looking all the way up to 1080. So if I add 360 degrees again, so I want to get there again, I have, instead of just 270, I'm going to have 630 degrees. Now, I can add another 360, and that's going to get me to, I should say, 990 degrees. And that's what my 3 theta would be. Well, I want theta by itself. That's what we're kind of solving for here. So right away, I'm saying to myself, how do I get theta by itself? Okay, I just need to divide everything by 3. That way we can get down into our 0 to 360. Okay, so theta divided by 3 is 3, which is equal to 90 degrees. And then we have 210 degrees. And 330 degrees. I don't know why I was writing on 2 ones, saying a letter or something. So 330 degrees. Okay, so that would be my answer. Okay. So pretty straightforward. The big thing is to think about is your unit circle and where those angles are. Now we're changing it up a little bit. If we're looking at this question, now we need to think, okay, we have sine times the cosine, and cosine times the sine in addition. Right away I'm saying to myself, that's a sum or difference property. It's got to be a, since it's sine cosine, it has to be a sum. So I have sine A plus B. Well, what's my A and my B? This has to be my A, B, A, B. And I know it's a plus, because this is on your salmon sheet if you're not sure. So we have plus. Well, let's just write in our answer now. So we have sine A is 2x. B is plus 3x, which that simplifies, remember, simplifies to 5x. Okay, now that we're at 5x, that is all equal to 1. Or negative 1, sorry. Negative 1. Okay, so we want to know where sine 5x is equal to negative 1. Well, and looky, right here, radians. And we want all solutions, not just a couple or from 0 to 360, we want all radians. Okay, so right away, I need to think, okay, sine 5x equal to negative 1. Right away, I need to think of unit circle, unit circle, unit circle. Where is sine any angle equal to negative 1? Well, right away, I'm thinking right here. So we're going to find that angle right there. In radians. Well, so we know that 5x is equal to, in radians, remember this is radians, in degrees it's 270 degrees, but we want radians, which is equal to 3 pi over 2 radians. So 3 pi over 2 radians. Okay, but think about this now. We need all solutions. So we're going to add 2 pi and then k. K is in, or where k is in integer. Which I'm going to write integer as that weird looking z. So it's like a bolded z. I'm going to write it that way from now on. Just to save you some time and save me some time. So we're not writing this together. And I'm still talking, so I'm pretty sure you want me to stop talking and just keep going. Okay, so now we want to get x by itself so we can figure out what angle we're working with, or what x is, I should say. So we're going to multiply, or divide, I suppose I could say divide half out with which is really multiplying by 1/5. Multiply by 1/5. So now I'm going to have 3 pi over 10 plus 2 pi k over 5. Okay, so and we can simplify further if we want by getting common denominator. So we're going to multiply this half by the top by 2 and the bottom by 2. I will just write 2 to get common denominators, which is equal to 3 pi over 10 plus 4 pi k, don't forget that k, over 10. And then when you get here, you can't, because you have this k back here, that's just like saying 2 plus 2x. We can't do anything because we don't have like terms here. So really this is just 3 pi plus 4 pi k all over 10. For your answer, I would be happy with this or this. Either way, I'll take that answer. Okay, so let's go to the next one. Keep everything moving so we can get you guys doing whatever else you want to do. Okay, now we want to find all degree solutions. Right away, first thing I see is the 2 here and nothing there, but we have a like term there and there. So I'm thinking I should be able to factor this, and looking at it, I can. So first thing I want to do is write my 2 sine 3 theta, and I'm going to write my sine 3 theta. That way I can get my first term right away. So now I need 2 terms that multiply to become 1, which is just going to be 1 and 1. Now think about your signs. We need a negative sign in the middle. So we want this sign to kind of take over what's going on. So we're going to have a negative because our outsides are going to multiply, and a positive. Okay, so right away when I have that, I know this is all equal to 0. We just can bring that 0 right down. Okay, so now we're thinking, okay, how can I solve for theta? Well, right away what I want to do now is set each term, this term, and this term equal to 0. Equal to 0 for both those terms. So we have 2 sine 3 theta plus 1 equals 0, and sine 3 theta minus 1 equals 0. Okay. Now the key is to just solve so sine is by itself. So after you subtract the 1 and then divide everything by the 2, you get sine 3 theta. It's equal to negative 1/2. And then on this side, you get sine 3 theta, which is equal to 1. So just because I'm looking over here and seeing the 1, I'm going to work with that side first. I want to get all the points I can as fast as possible, so I'm working with this side first. Well, I need to think back now to my unit circle once again. This is just like the problems before. Think back to my unit circle. Where's sine? My unit circle. Where is sine 1? Sine is 1 up here. Okay, so that's one place. Okay, so, and then what's the question asking? I should have said this earlier. Find all degree solutions. Okay, so we know that 3 theta is equal to, since we're working with degrees, 90 degrees plus 360 degrees, k. So k is an integer. Okay? I'm going to write that off. Integer. Remember that weird symbol? Z bolded. Okay? Well, right away I'm thinking to myself, well, I want to get theta by itself now. So I'm going to have theta equals, if we divide this by 3, and this is our term by 3, we get 30 degrees plus 120 degrees times k. Once again, that's for k being an integer. Okay, now we're going to go over to this side. This angle is a little bit more different, or not really more different, I should say. It is different. Negative 1/2, it's going to be an angle that we know. Since it's sine, we are going to say it's in quadrant 3 and 4. Well, right away, since it's sine, I can go change colors here. Negative 1, and then we have a 2. Negative 1, 2. And then on the top, we have the square root of 3. Negative square root. Okay, right away, we should be thinking, okay, since this is 1, this has to be a 30-degree angle, and this has to be a 30-degree angle. Remember our 1 square root 3, 2, or 1, 2 square root 3 angle, 30, 60, 90. Okay. So now we have 3 theta. We're looking at those angles, and remember we need all angles. So 3 theta is equal to this angle and that angle. So we look at it. I'm looking at my reference angle. 360 minus that 30 is 330 degrees. I'm right there. 330 degrees plus 360 degrees. Okay. Once again, remember this, for k being an integer. This is huge right here. You don't write this, that's the difference between a right and wrong answer. So now we also need to look, that was this angle. Now we need to look at, or I should say, I'll do different colors. That was this angle. Now we need this angle. Okay. So what is that angle? Well, we know the reference angle here is 30. Well, 180 plus 30 is 210. 210 degrees plus that 360 degrees k. For k being an integer, I'm going to keep saying that because some of you are going to forget it. So now we want to solve for just theta. Well, we have 2 different terms here. I'm going to say or that because we have 2 different angles we're looking at. So theta is equal to, we're just going to divide that 3 out of each term. So it's going to be, theta is equal to 720 degrees. Plus 120 degrees, and need to drink water here apparently. K, don't forget that K. Okay, so, and then the other one, so that's this one. Then the other one is going to be, remember 330 divided by 3 is 110 degrees plus 120 degrees. Okay. And what's that K mean? It's an integer. K has to be an integer. So if you put a fraction in there, it is not going to work. Okay, so don't forget to do your summary of the unit. I might be reading these off in class, so write me something good and something that makes sense, please. And then there's your assignment for in class. We'll see you tomorrow.